Okay. Hi, Mary and Daphne and Natalie Kaiser. Yes. Hi, it's me. And all your friends in math. All right. That was horrifying. Okay, so we're going to do the warm up together since I feel like this might be a new skill and I just kind of want to show you how to do it before you get going. So in number one, right? When we're examining a limit algebraically, we have this little tiny number down here as x approaches 2. We're going to take that 2 and we're going to substitute it into the equation 5x cubed and we're going to evaluate it. That's going to tell us the y value that the function is trying to achieve at that specific x value, but we just did it algebraically. If you wanted to, you could graph it on a graph and look at when x equals 2 what the y value is, and you should get the same number. Okay, so here, when you substitute the 2 into the equation, the limit disappears. So you now have 5 times 2 cubed. Okay, limit went away, 2 went in, bada boom. 2 cubed is 8. Our answer is 40. So we're trying to go on how to do this without a calculator, but I do want to show you that, like, visually what we're doing is finding the y value that the function is when x is 2. Yeah, you making the connection between what we're doing and our answer. Okay. So number 2. Let's put this guy in here.
Wait a minute.
That is undefined.
You can't do that.
So whenever you have 0 over 0 after direct substitution, this is called an indeterminate form. We're going to learn more about indeterminate forms after the IB exam, but basically you just have to know that you can't divide 0 by 0. Think about that for 1 second. Your brain is exploding, right? So what we want to do is get 0 over 0. It means that there's a hole in your graph at that specific x value. So what you can do is algebraically manipulate the original, try to get it into an alternative but equivalent form, then resubstitute and see what happens. So what you can do here, since it's a polynomial, is yes, you can factor, see if any of the common factors cancel, because what makes a hole in a graph? Common factors canceling, right? See if you can factor this guy, find any common factors, cancel them, and then see what you're left with, okay? Does anyone remember what that rule was called where common factors cancel and they make a hole? You guys' name sounds like hole.
It's like called
Paul holes? No.
mold.
Moles. No, L'Hopital's rule. Remember.
I think it's probably mold.
Hospital rule?
No, definitely call it hospital rule.
Hospital rule. Next, you fall into a hole, you're gonna have to go to the hospital.
Okay. So now I'm trying to rewrite this guy in an alternative form that's equivalent but looks different. Maybe I won't get an indeterminate form then, okay? So now I'm going to do x minus 1 over x squared minus 1 is a dots, x plus 1, x minus 1. Notice how the limit's still on there. The limit's still on there because I didn't substitute him in yet. Once I substitute him in, right, meaning once I take that 1 and I put it into the problem, then the limit disappears, okay? So, like, I feel like kids always, there's, like, stray, bizarre, like, limits left over. when I'm grading these. So just kind of like draw attention to the fact that when you substitute the x value in, the limit notation disappears, okay? So now you just have 1/2. Oh, is 1/2 an indeterminate form? No. He's a number. I'm done. You got an answer. It's a y value. So what does that look like on the table, right? Check it out. Okay. Okay, so like I graphed the original function before I canceled anything, right? And then I look at the table. I'm going to change it from auto to ask. Everyone knows how to do that, right? Do you have a calculator in front of you so you can follow along and learn?
No, but I can look at it.
Are you sure? It feels like that method hasn't served you well in the past if you still don't know how to do it.
Oh, no. I haven't looked.
Oh gosh. Okay. Help for $1 a day. You can help this man. Okay. So now we are looking at the x value of 1, right? When we type in a 1, what happens? Don't even just guess. What's going to happen when we type in a 1?
Undefined.
Undefined. Undefined because there's a hole. Good job. There's a hole. Okay. So then if I'm envisioning like a number line, right? And there's a 1 on the number line. What number is very, 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 very close to 1 on the left? 0 is kind of close to 1. If I type in a 0, he's going to have an answer, right? Yeah. 0.999. That's a 1. 0 is close to 1. I see what you mean. You're good. All right, so let's type in 0.9999. Oh, yeah. Okay, let's examine what's happening on the right, right? What's a number that's really, really close to 1, but it's on the right of 1 on a number line?
1.001.
Yeah. Oh. What kind of number is that? What's it close to? Okay. So what's the limit as x approaches 1 on either side? 1/2, which is what we got. We had to get rid of the hole because when we type in 1, it just gives us what's happening. A hole. Algebraically, no, he's a hole because he's a common factor that cancels. So algebraically, we're like, here's what we're going to do. We're going to cancel the common factors. That's just going to give us the idea of what's happening on the graph really, really close to that number. But we can't find out what's happening right at that number.
So I figured I need to figure out what the hole is, and then you just take the number that's like close to it.
Well, no, I'm just like helping you make a connection here. You are supposed to do these without a calculator. I'm just showing you like what's happening. You know what I mean? I'm showing you what's happening. This is why I can't record. I'm too weird. It's like it's just everyone's gonna listen to this and be like, what are these voices? Who are these people? What's going on? Okay. What about number 3? What do you think? Let's substitute in 3 and see what happens. I mean, it's number 3. We're substituting in what x value. Sorry, that was confusing. Nah. Oh, whoops. No. What do we do now? Oh my.
So you only pull out the positive, right? From the square root?
Now
Like
you
the
can
square
do,
root
wait.
of...
You got an idea?
You can do square root of x plus 3, square root of x minus 3.
Yeah, that's
Yeah.
Oh my god, that's what
What
I
is
did.
that called?
Oh, multiply by the
Hospital rule.
No. So you got an indeterminate form. What is the math telling you? The math is
There's a
telling
hole.
you that you need to.
Fix it, some factor.
There's a hole. You need to fix it somehow, right? So think about this is like the second thing that we're learning about, right? the first thing you learned about was cancel common factors, rewrite. This guy isn't going to have common factors because he's a square root, right? It's not like a polynomial, like his factor and cancel stuff. This is where our very special friend enters. Does anyone remember what he's called?
Hospital?
You have to whisper it. Right? In order to rationalize the denominator, you multiply by the conjugate, ratcon, rationalized conjugate. Yeah, so you got a ratcon, baby. Let's ratcon. Here we go. Okay, so think about it, right? Which guy is the conjugate? Like, what is a conjugate? Yeah, good job. Okay. I thought I was gonna have to dig more there. Good job. All right, so we are trying to find the conjugate of this guy. Why are we finding the conjugate of this guy? Because if we find the conjugate of it, ultimately that square root is gonna go away in the denominator. Okay? Like, look what happens. I'll do it the long way. Eventually you'll be able to see like what happens without having to do the like long work, but I've basically multiplied by a smart version of 1. The smart version is the conjugate, rad x plus 3 over rad x plus 3. I'm going to distribute on top and on the bottom and see what happens, okay? So I'm doing the work off to the side over here, kind of. Uh-oh, that looks like a hot mess. That's okay. And then on the bottom, what do we get here? Let's see. We've got...
Miss Falchuk, I think you did that the most difficult way possible.
Why?
Well, because can't you just factor the top?
It's x minus 9.
No, you do square root of x plus 3, square root of x minus 3 on the top. And then you put it over square root of x.
Oh, yeah, you could have those cancel at the end. You can do that if you want. Sure. We could do it your way. Sure. That's fine.
Wait, no, I don't like his way. Sorry.
Yeah, I don't either.
It's so much easier.
I'm never
so
going to be able
less
to
steps.
think of multiplying radical of 3 minus 3 and radical.
We'll show you Logan's way after. How about that?
Sorry.
Nice job, though. Okay. So now what cancels? These cancel, right? Okay. And then you've got some hot, disgusting garbage up top. How do we stop it? How do we stop the hot, disgusting garbage? Well, Wait, actually, Logan's 100% right. We would have to actually not expand the top because then they would cancel and then you would get your nice thing. Good job, Logan.
So you only rack on the bottom?
No, you rack on the top because you've got that factor up there. But you need it up there in order to have them cancel. You know what I mean?
Oh, that's what.
Yeah. Nice job. So then now you've got your two factors canceling here, rad x plus 3. Look at our garbage. We made it stop. Now we have the square root of x plus 3. So I've got my limit. Where is he? Limit as x approaches. Where is it? 9. And then now we're going to do our substitution. So the limit notation goes away. So that's going to be 6. Yeah, good job. Nice. That was good. Hooray! Oh, there is a whole other problem. So the next one, right? Is everyone having a hard time thinking where to start for the next one? In the next one, we're not going to learn how to do these algebraically by hand until after the IB exam. For something like that where it's super difficult, you would just graph it and take a look at the graph. So graph this guy and take a look at the graph. What? Okay. Why didn't it sign me in? Whatever. Okay, so what's the y value the function's trying to approach? You could also pull up a table if you want, but it's kind of obvious. What's the y value on this guy?
One or one.
One, right? Yeah? Cool. And then if you just want to double check, Control T.
I'm singing.
He's going to be undefined because if you direct substitute it in, you would get 0 over 0. But looking at the graph, you can see that on either side, it's approaching 0.841, 0.841. You could do menu, table, edit, ask. You can go really, really close to 0. What would be really, really close to 0? I feel like people always mess this up, kind of.
Negative 0.001.
Yeah. Okay, there you go. And then what about on the right?
0.0001. Well, check, how do I get my calculator out of
So you can see it's 1. You visually saw on the graph that it was 1. When you evaluated it right at 0, it was 0 because you can't divide by 0. What was that question?
Guess how to get her calculator out of test mode.
How did it even get in test mode? You have to
It's my calculator, like at home.
like hook it up to a special cable to get it.
Are you joking me? At one point I did.
It's not set to press the test in there though. It's just hilarious. Some bizarre combination of calculator strokes has brought you to press the test. It's okay, I'll fix it. I have to fix it with a cable though. Just to give you an idea of how
So how did I even get there?
that should be someone's IA. What is the probability that your backpack puts you in press the test? Okay. So now we have the computational rules for limits, okay? These are like prohibitively complicated looking, but you should just have seen them before just so you can have an idea of them. Let's break down what they're really saying, right? The limit of a sum is the sum of the limits. That's saying that if you had like the limit of x plus 2 plus 5 x squared, you could break it up where it's the limit is x plus 2 plus the limit is 5x squared, and then you could just like plug it in either way. Saying that you can break up things split up by pluses and minuses and just substitute the limit in each term. Like they're kind of common sense, but they're kind of hard to explain, right? Like, okay, yeah, we got it. We already did that. What other ones are interesting? This is the same thing. It's just this is plus, this is minus. Limit of a multiple is a multiple of the limit. So it's basically just like you can factor out a constant and the limit remains the same. You just multiply that limit by the constant at the end. These are not particularly useful. The limit of a product is the product of the limits. Got it. The limit of a quotient is the quotient of the limits as long as you are not dividing by 0. This becomes useful in like 2 days. Not just yet. Okay? They're here. But what I really want you to take away from computing limits algebraically by hand is the following decision tree. This is limits and u. Limits and u. This is what you do when you get to a limit, okay? 1. Plug it in. If you plug it in and you get a number, think of it in like my Long Island voice. You're done. You plug it in and you get a number, you're done. That's the answer. That's the y value the function is approaching. If you plug it in and you get 0 over 0, he's an indeterminate form. What do we call him? Or what do you have to do? There's a hole, right? You're going to need to do a rewrite. Rewrites could include factoring, RatCon, and then we're going to do examples with an LCD a little later. Okay? You need to do a rewrite. So it's kind of like this is like mini step 1A or 2A, 2B, 2C, 2D is holy scary. Now you're going to resubstitute into the new form. You should get a number, and then that's your answer. If you don't get a number, that means maybe you missed a factor or like you didn't pick the right LCD or something. Once you do the algebraic rewrite, you should get a number when you resub. Okay, or there's a third scenario, which we didn't do yet, but we will get to. You plug it in and you get a number over 0. The number over 0 means that you have an asymptote. You have a vertical, asymptote. I'll show you how to do these by hand. I think tomorrow or the next time I see you. And then for today, just think graph and look. And see what that y value is on the graph. And then that's your number answer and you're done. Do you see how you start and finish each one of these problems?
Yeah.
Okay. This is a bad explanation. There is only one step. Step 1, plug in. That's okay. You get it.
This is CYX. A Y value.
Sorry. You guys good? So your goal at the end of this class, I would like you to be able to look at a limit problem and know what to do.
Yeah.
First method, direct substitution. I purposely picked scary ones to see if you understand what I mean by direct substitution. The first one isn't too scary, but using what you just learned about direct substitution, sub in the x value, see what you get as the y value, okay? Don't get freaked out. You got this. 3 minutes, 5 minutes, whatever.
Are we allowed to use our calculators?
Yeah, you need it for the last one in degrees. The other one, try to do it with the chart.
Wait, what?
The trig chart.
Oh my god. It's just, I know what it is.
Do it without the chart.
Oh, okay, hold on.
This is not hilarious.
This is my final answer. Miss Walker, did you know that? You can't go to cosecant and S mode?
Wait, really? It's like sine, cosine, tangent, fine. Cosecant, get out.
It has all like the -1, but then like once it gets over there, it says no, it won't let me. Here, borrow mine. This is tomfoolery. Thank you. Yes, it is.
That's her boyfriend.
Yeah, I'm married to somebody.
Then you have to multiply it.
All right, guys, let me see your homework from last night. Show them.
You can't sit.
Oh yeah. Yes, got a paper cut. Oh my god, that's scary. Hey, those are spider bots. I can come back. I can.
No, here you go.
Hi, Bill.
Yeah, it's alright.
Are you okay?
No, I'll be alright. No one really spider cross.
Yeah,
Tom's a lucky man.
Wait, I thought it was
No, that's the opposite of scurrying. That's not on the scale. Nice.
It would be 5 tiles. Which is easy.
Scurry is small.
I know. I do everything.
On this clock, this is.
See, you're messing up here.
Oh,
That-
good.
It should just be signed.
Oh, yes, we heard the.
That's all.
Can I say
Yeah,
no?
the turn
Yeah.
Oh, okay.
Or no, but it's over one.
I was standing there talking to Deanna, and all of a sudden he starts looking over at me. And I said, you know, you got this. And I was like, "There."
Nice.
What?
Yeah.
I don't know.
No, you didn't.
Or did you draw a long time?
You just type in your calculator. In degrees. Okay. How'd you guys do? Check it out.
Oh my God.
Now, ordinarily, you wouldn't see the degrees part here. I just put it in there so you knew what mode to put your calculator. What?
It's the same thing.
Oh, we can use our calculator on these?
Because 2 squares is 3 over 3 is the same thing as 1 over 3.
Oh, okay.
Yes, I just checked. No, I just know that off the top.
Well, I don't know because you didn't check the first time.
You didn't look like you checked.
He's so mean.
No, because I was like, oh, you would have
Wow. Just wow. Okay. Let's look at A, B, and C. In this part, okay, I used to call it a Dwight moment, right? When you get 0 over 0. And it comes from in The Office when Dwight rips off a CPR dummy's face and puts it over his face. And it means that, does anyone in here watch The Office?
Yes.
Oh, okay. All right. Okay.
Wait,
Because
no, I watched
in the other class, I said Dwight moment, and everyone was like, and I was like, do you guys watch The Office? And they're like, no. And I was like, okay, never mind. But what I mean is that there's more underneath. You got to rewrite that thing and check out what's really happening underneath. Okay. So you need to peel off the CPR dummy mask and you need to see what's going on. Okay. Let's look at number 1. Factor and cancel common factors, then substitute again into the new form. So this is what happens when you get a 0 over 0. So what I do need to see is your first initial substitution, because that shows me that you know what to do, and then you know how to make a decision based off of the mathematical results that you get. So always, always, always direct sub first. Get the 0 over 0, then do your canceling and all that. Because sometimes it looks like it's going to be a problem, but then it's not. So always direct sub first. Dwight. Okay. So plans for this guy, right? I could factor out a GCF of x squared. Or I could just factor out an x because I know it's going to cancel with the denominator. It's up to you. You're going to get the same answer anyway. You're just going to have it in like a different factored form at the end. I just pulled out an x because I'm like, all right, I know they're going to cancel. Yeah.
If I took out an x squared, is that fine too?
Yep, that's what I said at the beginning. What? Was you going to say something else? No. All right, what about the next one? You try the next one, okay? Do you think you can do it?
Yeah.
Do the rect substitution first, get 0 over 0, then factor cancel, resubstitute, okay? I'll do it up here if anyone wants. Oh, gosh.
Not over anything.
I'm not gonna say one over one.
Why should I?
Oh, people call it
No, I love saying so basically. Yeah, always has.
Okay, imagine seeing people in your That's the key.
Wait, what's? Small chat.
What's up?
The 1C, is that the?
Oh, it's the sum of two cubes. Either you remembered it from last year, or you could look it up on your phone if you don't remember it. It's like two perfect cubes, right? X cubed plus 1. Yeah. You don't need to memorize it for IB, for like this test, but like I just put it on there because I needed some interesting ways to have people factor. Yeah.
Would they take points off if we rewrote like limit of x to 5 of 3x squared minus that equals whatever it is? Or should it be the new equation that we just had?
Can you write it on the board?
Yeah, right. Okay.
I'm sorry. I have to like see something, or I don't
We
know
find
what
out
you're talking
whatever it
about.
is, and it's like the limit's like. Can we write limit of x to 5 of 3x squared minus 15x over x squared minus 25? Or should we write?
Sure, yeah.
Okay.
Like that is the answer. But if you do all this work and you just end up with a 2/3 and you circle it, like I got it.
Okay. Or should we write like that? Right, because this one's equivalent.
They're the same.
Okay.
It doesn't matter. But this is just like extra time.
Oh, okay.
You get 2 over 3 at the end. I got it. I don't think it's 2 over 3 though. I think that was just an example.
So we see you minutes.
Oh, you factor the top. I need to touch the top.
All right. Now the next one is kind of tricky. Maybe you remembered it from last year, maybe you didn't. You don't have to remember the sum of two cubes, but I was trying to look for like creative ways to get you to factor. This can be factored. It's called the sum of two cubes. Did anybody learn this last year? If not, just like for a second. No. All right, cool. Well, it's okay. You just basically. Oh.
So we did learn that, but we just forgot about it.
Oh, it's like think of like this as the we did learn it. We just think about it as like the first cube is this guy, the second cube is this guy. Right when you factor this guy, it's gonna be. Do you remember like a plus b times a squared? Yeah, you guys remember it? Yeah. Minus no. I think it's like a to b blah blah blah, blah plus b. Yeah. This is a plus b.
Yeah.
Yeah. Yeah. So here you would just like take this guy, right? And you would be like following the same structure. You would be like the limit as x approaches -1 of, and then you would just do like sum of two cubes for this guy, right? You would do x plus 1. That's like the first thing and the second thing, right? Times the first thing squared minus the thing in the middle. There you go. And then all over x plus 1, x minus 5. Okay? Ooh. All right.
That's 2 because it's. Oh wait, I thought you doubled that. Oh, do you square them? Yeah.
All right, cool. So that was like the hardest one I could think of for factoring. Okay. You would never see sum of two cubes or difference of two cubes. But just cool. Yay. All right, let's try the next ones. Racon, your favorite. Wait, Sydney, is this Tom? Okay. Try these, guys. I'll help you write them, and then I want you to try them on your own, okay? Hello. Let's look at the first one. Since there's radicals, we're gonna rationalize by multiplying by the conjugate. So what would the conjugate of the first guy be? Well, first you would do your direct substitution. Let's do our direct substitution together. Let's get to our Dwight moment. What am I doing? Oh. My brain just went on vacation. Okay, here we go. All right, guys, let's get the conjugate going, and then you can finish it up on your own here. What would the conjugate of this guy be?
Or the square root of x.
Yeah. A lot of people are like, wait, do I change the thing under the radical? No, don't change the thing under the radical. Change the sign on the inside.
Well, that sucks, doesn't it?
Or the outside, you know what I mean. Okay. And then you can do your little multiplication off to the side. Make sure you are practicing rewriting the limit with each and every step that you do, and then have it disappear at the end, just so you're tracking your work.
I'm scared who it's gonna be.
Wait until this is what Logan was saying earlier, right? Wait until you expand the top to see if anything's going to cancel with the bottom before you expand the bottom. And again, I am working into the next problem. Let me go drop it down. Here we go. All right. So good to know.
I have to censor my lessons.
See, this is why I hate being recorded. It's too much.
Could you imagine?
She was talking like the rat.
Yeah, just wait.
Oh, I was gonna say.
Wait.
Miss Falk.
I actually can't.
This is like
Okay, I got this. I just erased my work.
Trust and believe in yourself, Yana.
I got this. Why am I getting blue?
Okay, I'm going to do this.
Now I've got it.
I got it ready.
Come on. Okay. All right, guys. The next one, I'm going to do it in a different color. Let's take this scary guy from scary to not scary. How can you rewrite him so he's not?
Square root of x is 1 minus 2.
Try rewriting him with the square root, and then you'll feel less afraid. You'll feel less afraid. Okay? Okay, now it's super obvious, right? All you have to do is multiply by the. Yeah.
No, please.
No. You lost
Oh.
Wait, is that what? So if we retcon, are we retcon Amos? Retcon Amos.
Oh, you better point it.
Oh my god, yeah. Where should I bring it?
On the paper.
Right on the board. Giant letters.
And plus, isn't that something for?
Right.
Guys.
I've been seeing this whole time, so it's okay.
Unfortunately, she's not.
All right, so just so you could see, I had to like do it off to the side. That guy ended up there. Okay. No, I didn't skip them. I like ran out of room. Here, I'll show you. Look. It's like, so I did this part. Down here, I just like rewrote it and didn't multiply anything out. And then I did this part over here, like expanded this part over here, got that, put it here. That's why I didn't.
No, she can't.
Show up. I don't want to go to the school.
It's just me and her girls.
All right, this is the third thing you could possibly have to do when you do an algebraic rewrite. What are the three things available to you? You get a 0 over 0. You need to rewrite it. LCD, this is the third one. Hooray. Okay, so you use LCD when you have complex fractions. Complex fractions are a fraction over a fraction. Your favorite. Okay. So when you have a fraction over a fraction, what you're going to want to do is multiply the top and the bottom of the fraction by the LCD of the complex fraction, right? So like this is the complex fraction, this is the fraction within a fraction, right? If you were to get a common denominator between these two, what would it be? 2 times 2 plus x, right? So that would be the LCD. So what you do is multiply the top and the bottom by the LCD. That's like a quick way of clearing the fractions up here, and then you just get one nice fraction. Okay? So do LCD of the complex fraction. CF, complex fraction. Okay. So what's the LCD of the complex fraction here? We'll do our direct substitution right up top. 1 over 2 minus 1/2 over 0 gives me 0 over 0. Here we go. We're off. What?
Hold on. Oh.
Okay. You just know that, like, if I wanted to find a common denominator between 1 over 2 plus x and 1 over 2, right? If I wanted to find a common denominator between these two guys, right, I would multiply this guy by 2.
Oh, okay.
And then I would multiply this guy by 2 plus x. Right?
Oh.
So then I would get 2 minus 2 plus x over 2 times 2 plus x.
Okay, got it.
Thank you.
Yep.
So then now, so when I multiply by the LCD, it's going to look like this. Okay. And if you're comfortable with this, you can see that like, oh, if I multiply the top by 2 times 2 plus x, like certain things are going to cancel. Like you'll get better with these as you go through them. But for now, for this first part, I'm going to do the long way so you can see everything that goes together and cancels. Okay. So it's like this whole piece times 2 plus x. Yeah, this is like me working in the numerator right now. And then here's what I mean by like, you'll start to see the stuff that cancels. Go back to the black color. Whatever. Okay, so that's on the numerator. And then on the denominator, I would have 2 times x times 2 plus x. I just multiplied these two. All right, so now you'll see the stuff that cancels, right? He cancels.